Alright, in this video we're going to discuss a little bit about randomality and also how to use that randomality with our array structures. Okay, so it's common to have a collection of items and then randomly select one, for example, or to have a collection of items and shuffle them up. Alright, so first we're going to start in with randomality, a little bit about the Math.random function. So console.log, and math, it's capital M, A-T-H, is a built-in object. It's globally available, and it has a property on it called random, which is a function. And if I call this function, it generates a pseudo-random number. It's not truly random, and the difference between pseudo-random and truly random comes down to mathematics mathematical definitions that are sort of beyond what we're talking about here. Just know that it's not purely random, and it's cryptography, for example, relies on really strong random numbers or pseudo-random numbers. So this is not good enough randomality to be used with cryptography or something like that, but it's perfectly fine for using with interactive types of programs and games. Anything where you want to sort of simulate the idea of random numbers, right? So here I'm logging math.random, and the name of this program is array random, and I can just clear my terminal here and I can say node array random, and when I run this I get a number between 0 and 1. 0 is a possibility, 1 is not. Okay, so in mathematical terms this prints a number between the interval 0 and 1. Okay, so the square bracket, this is mathematical notation. The square bracket means this value is included. So it includes 0. It's possible that it can be a 0. The 1 means it's, the parentheses here on this interval means it's excluded. So anything up to 1, but not 1 itself, right? So this is going to give us a random decimal value between 0 and 1, but it could possibly be 0. Right? And every time I run this, because it's random, it's not the same value, it's a random value. Right? So we can see the benefit of this for something like if we wanted to roll a dice or flip a coin. Right? So we can make a couple of really simple programs here. Function flip. And we could say if math.random is greater than 0.5, right, then we want to console.log heads. All right, and then otherwise console.log tails. Right? And we can do this in a loop if we wanted to. For let I equal 0, well I is less than 10, I plus plus, and we can just call flip. This is going to flip a coin a bunch of times, and we'll see it. And it'll be different each time. So we only got 2 heads that time. Right? This time we only got 3 tails. Right? But you see it's random, or pseudo-random as we would say. So what we could do is if we wanted to, we could keep track of, which one is returned. Right? So we could instead of just logging it to the console, we could return the value, return heads, and return tails. And then we could keep track of, how many were flipped, right? So let results. We're going to make this an object, and we're going to say, we're going to give it, we're going to make this lowercase heads and tails, and then we'll give these key names heads, and set that to 0, and tails, set that to 0, and then as we get more and more of these, as we flip, we're going to get a result, either heads or tails. Actually, I'll keep these capitalized just to show you the lowercasing function. So whenever we get a heads, when we call flip, we're either going to get this string heads half of the time or this string tails half of the time. Right? And that'll be the result of the flip. Flip result. Okay. So if we get heads, that's flip result, right, with a capital H. We want to basically say in our total results, we want to look at the flip result, right, which this could be heads with a capital H, right, but our object, our property in here is heads with the lowercase h. So what we want to do is say .to lowercase and then plus equals 1. Okay, so this is just incrementing the item here. It's as if we said right? This is just incrementing the value stored here. But the way we're doing it this way is whatever is flipped. So this could be tails, and then we just take the lowercase of that property name and increment that one. And then we can log out, the percentages. So how many times do we want to do this? We can say something like const total flips. And we'll say maybe we want to do this 100,000 times. Let's do 1,000,000 times for fun. So this is where playing around with computers can be fun. You can do outrageous things like flip a coin 1,000,000 times. So this loop, instead of running 10 times, we want it to run total flips times. Right? And then we can calculate the percentages of each one. We can say console.log heads occurred we'll just list out heads, and we want to calculate the percentage. Okay, so we'll say results heads. That's going to be the actual number of heads. So if we divide by the total of flips, then that should give us the percentage. And if we actually want, it'll give us the decimal between 0 and 1. If we actually want percentage, we can multiply that by 100. And then do the same thing for tails. Okay, so you did it 1,000,000 times. First of all, note how quickly it happened. Where did we? Seems like it printed an extra value here. Oh, that's our random number that it starts with. All right, so that's this up here. We can cancel that out. All right, but 49.97 and 50.02. You can see that's pretty close to fair. It's pretty close to random. There's always going to be, anytime you flip some coins, there's going to be some more heads or some more tails. But you see, as it approaches a high number, it gets more and more accurate. So let's start with 10. 40% and 60% heads. That seems like a large variance, but there's only 10, so that's not really that much. That just means 6 heads and 4 tails, right? So we'll put the percent sign there so everybody knows that's a percentage. All Right? So with 10 values, it's unsurprising that sometimes you'll get like 7 tails and 3 tens. With 100 values, 70% for one of them would be very unusual. But you're still going to get, oh, that was really good, 50-50. You're still going to get some wild variance, right? So this difference just has to do with the way JavaScript calculates, stores its numbers, and we'll go into that. That's an advanced topic. But see, we're still off by like 6 or 7 here and there, right? So it's not super unusual. Here, this one's off by 20, right? That would be really unusual as we approach more and more, like as we approach larger and larger numbers. So here's 10,000. And so now it would be really unusual to get something like 60%. We can run this a bunch of times, and we really won't see much beyond. There was a 48, right? But we won't see much beyond that. And especially if we go on up to the millions. So here is 1 million. Let's see how fast we can do 10 million coin flips. It'll take a second there, but not too long. It's pretty impressive. It does 10 million coin flips like that. All right? So this is an example of coin flips. But what if we had 3 things, like paper, rock, scissors, that we wanted to deal with? All right? So yeah, let's go ahead and make this another file name. So this is flips. I'm going to duplicate this and call it rock, paper, scissors, RPS. Now if we wanted to do the same thing, you know, this would be, the function name would be called shoot. You do 1, 2, 3, shoot, right? Since there's 3 things, we would have to have a longer if-else statement, right? We would have to say this is, if this is less than, you know, 0.3333, right? Else if, right? And we would have to store the random number now, r equals Math.random. Alright, so if that random number is less than 1/3, if r is less than 2/3, something like that, whatever it is, and then so this would be, you know, rock, paper, scissors. Alright, so we can kind of do this, but this feels not quite right. First of all, because, you know, there's 3 items, we have to divide this interval into 3 separate parts, right? So up here we were talking about the interval going from 0 to 1. When there were 2 items, we basically divided this interval into 2 sections, right? For 2 items, we divided the interval into the sections, 2 separate intervals, 0 to 0.5 inclusive to, or, sorry, this one is inclusive, that one is exclusive, right? So we're catching 0 in there, so we're going from 0 inclusive to 0.5 exclusive, and then the other interval, so this would have been heads, the other interval would be going from 0.5 inclusive to 1 exclusive. Right? And so we can see that these are equal intervals, right? And so when we said if r is less than 0.5, that would be anything in this interval. That's heads, right? But with 3 items, we have to divide the interval into 3 parts, right? And that becomes harder and harder to sort of do in this manner, and it's not scalable. So if I had, say, 100 things, then I'd have to divide the interval into 100 items, right? So that's not necessarily the best way to do things. This will work, right, but it's not ideal. So here we could have heads, tails. This would be like rock, and then paper, and scissors. But we wouldn't really want to keep track of these things the same way, right? Because with rock, paper, scissors, you always play against somebody else. But the idea here is we have this shoot function, right? And so we could, for let I equal 0, we have some number 10. I suppose we could just go back to where we were with and keep track of it. So rock, paper, scissors, we have results, we have total shots, and to do the same thing, flip result. Here it's going to be shot result, so you shoot, and we'll just call that res. And results, res 2 lowercase plus equals 1, and then we could just do this for rock, paper, scissors. So we can do this, and we'll see what percentage of each. Array random. Oh, yeah, I changed the name here. So this is RPS, and it's not total flips; it's total shots. All right, and let's move this down a couple. There's 100,000. All right. And pretty close. We forgot under here, scissors, 0. Is that not a number? I misspell something here. LCS. Otherwise return. Oh, I have scissor instead of scissors. Alright, so that should fix that. Alright, so each one of these is about a third. But as I said, the items of things you're selecting from randomly becomes bigger and bigger. It becomes harder and harder to do this manual dividing of this interval. Right? We had to divide it into 2 things, and now with 3 items, we had to divide it into 0 to 0.3333, then 0.3333 to 0.6666, and then that had to go from 6666 to 1, and this just becomes painstaking, right? And it's not as accurate either, right? Because we know this decimal isn't quite perfectly accurate, and what is a third, right? There we go. So a better way to do this is to sort of manipulate that number that you got based on the size of the number of things you're choosing from. All right. So if we have rock, paper, scissors, so we're going to call this function shoot1, and we're going to make a different function now. We're going to say let options equal array of all of our different options. So that's going to be rock, paper, and scissors. Keep them capitalized like we did there. Okay, and then we're going to make another function called shoot. All right. Now what we want to do is, depending on what options we have, we want to generate a random number. And wouldn't it be nice if we could generate a random number that was just randomly either a 0, a 1, or a 2, and we could plug that into our options array and randomly select one of these items, right? So if I picked a random number and it was the index 0, if I knew a third of the time it was the index 0, a third of the time it was the index 1, and a third of the time it was the index 2, that would be perfect, right? Especially if we could base this calculation on how many items we had here in options. That would be absolutely perfect, right? So how can we do that? Right? Well, when we think about the original interval, there are a couple of ways we can manipulate this interval. If I have a number between 0 and 1, when we think about these things, we need to think about the low end, the lower bound, and the upper bound. Okay? So if I wanted to scale this interval to make it a wider range of numbers. Instead of just between 0 and 1, I could multiply. So if I wanted to make this the numbers between 0 and 10, if I multiply the low side by 10, that's still 0, so the lowest this could be is still 0. If I multiply the upper bound by 10, that becomes 10. So our value becomes larger. The range of values, rather, becomes wider. It becomes scaled outward, right? So I can scale this by multiplying. You can also shrink it down by multiplying. I could multiply this by 0.5, for example. If I multiply by 0.5, the lower bound would still be 0, and the upper bound would now be 1/2. So I would have shrank the window, if you want to think of this interval as the window of randomality. It is the window in which you are drawing random numbers, right? So inside of the window, you're going to draw one of those random numbers. If you make the window bigger, then you can allow for different numbers, larger numbers, right? So that's scalability. You multiply both the lower bound and the upper bound by some value, right? And that scales it up. You can also translate the value. So let's say I wanted to pick a random number between 5 and 10, right? So the window size is between 5 and 10, so that's 5 items, right? So I would want to multiply by 5, so that would give me 0 and 5, but then I would want to add to both sides 5 numbers. So 0 plus 5 is 5, and then 5 plus 5 is 10. All right, so that's scaling and translating, and we're going to use those ideas with options. Options, the length of our list, right, is sort of our window size. Our window size, we want it to be between 0 and 2, right? 0 and 3, really. So if I generate a random number, so let R equal Math.random, my casing, right? If I multiply this random number by a certain scale, I could multiply it by 2, and that would give me the numbers between 0 and 2, or multiply it by 3, or multiply it by the length of my options. Options.length. Okay. So this is going to generate a number between 0 and 3. Not including 3. It can't ever be 3. But that's basically from between 0 and it's sort of like these intervals. It's between 0 and 1.0, between 1.0 and 2.0, and then between 2.0 and 3.0. So we could generate these 3 intervals from our one interval, right? So if the number lands between 0 and 1, right, that would be rock. If the number lands between 1 and 2, that would be paper. And if it's between 2 and 3, that would be scissors. So we have equal intervals here. So this random number, though, is going to be a decimal number. It's going to be somewhere in between these, right? But what we want is an index number. So it turns out there's a math function to help us with that called floor. So whatever value you give math.floor, we can open up Node interactively to see this, math.floor, if I pass in 1.4, it takes the floor. It truncates any decimal values. Right? If I have 0.98, it truncates the decimal values. If I have 2.98, it's 2. So what this essentially does is turns any one of these intervals into that lower bound value. So anything between these values is now going to become 0, which is great because that would give us the index for rock. Anything between these values is going to give us the index 1, which is great because that gives us the index for paper. Anything between these values is going to give us a 2, which is good because that's scissors. Right? So in this way, after we calculate R, we scale it out based on the length of our options, and then we take the floor, math.floor. Okay, and in this way, we're grabbing a random item from this list. All right, so if we just want to return, basically, then whatever random index we calculated there. All right. So remember, this is something common you'll do if you want to select something randomly from a list. Right? The options.length, you have to scale out your interval by the length of items and then take the floor. It's really common, and this is sort of the math behind it. Okay, so this is our new shoot function. This one's shoot1, so we're not even using this. I'm going to leave it in here though, just so you can see it. Maybe I should comment it out so you don't think it's don't accidentally think it's running. So here's the shoot function that we're using now, and we're running it in the loop, running it 100,000 times, and we'll see it should work close to the same way. And sure enough, it does. About a third of the time it's picking rock, a third of the time paper, a third of the time scissors. Okay, now a slightly different problem would be a shuffling problem. How would you shuffle these items? So if you wanted a list of items and you wanted to shuffle them. Well, one thing you could do is create a new list and then select a random item and then remove it from that list and add it to the new list. Select another random item, remove it from this list and add it to your other list, and then do that until there's no more items left. That's one way you could do it. Another way you could do it is to have a swap function that would swap two items by their index. So something simple like this function swap. It's going to take an index 1 and an index 2, and all it does is first you create a temporary variable to hold one of the values. So let's pass in the array that you want to swap items with. So here you take array at index 1, set that equal to temp. Then the item at index 1, you now set equal to array item at index 2. Okay, so now the item at index 1 is now the value there that was at index 2, but the value at index 2 is still what it was, but we need to set it back equal to temp. Right, so we would say array I2 equals temp. And that's all a swap function does. It just swaps two values. So here if we pass in the options array and we wanted to pass in swap 0 and 1. So that's going to swap these two. First we make a temporary variable and grab the item at index 0, that's rock. So temporary will be holding rock. Then the item at index 0, we're going to store the item at index 1, which is paper. So now our options would be paper, paper, scissors, right? But we have this temp variable holding rock. Now the thing at index 1, we're going to set back to what we had stored here, rock. So now this would be paper and rock. Okay, so if you have this swap function, then what you can do is randomly select two index values and swap them. And you can do that lots and lots of times, right? So what would a good shuffle be? You would think you would probably want to do that, maybe 4 times the number of items, something like that. All right, but that would be something interesting to calculate, right? You could do that a few times, but so let's say you did that just however many, like say if it was a deck of cards. If you did it 52 times, and there were 52 items, there's no guarantee that every index would be swapped with another. So you might still have some items in their original position, right? And generally in any shuffling, that's a possibility anyway. But if you did it 100 times or 104 times, there'd be less of a chance. Maybe if you did it 200 and 208 times, that might be the way to go, right? So that's another way you could shuffle. There's a bunch of different ways you can shuffle, right? Specifically, the swap method is good if you have to shuffle an existing list. The other way we were doing it, where if you randomly select one of these items, that's going to return a new list, a separate list. It's not going to shuffle the list itself in place. Okay. So anyway, that's some ways to think about randomality, intervals, and how to apply the Math.random function, how to apply that to selecting something from a list randomly, and then there's some tips on maybe shuffling up an array of items. Okay. So hopefully that helps and you learned a little something about randomality there. So this can be a whole lot of fun, making different types of games that involve randomality, random choice, that sort of thing.